what is an infinite sequence?
Doesn't it?
Yeah, it doesn't end. Good, Jacob. And if you were to look at an infinite sequence, it would be something that looks like this, like a sub n equals 3n minus 1. That's an infinite sequence. What that means is the number of terms that you could have in a sequence has a beginning, but it has no end. Okay? So you could keep going on and on and on and on. So if I said, what is the 100th term of this sequence, what would you tell me?
A sub 100.
A sub 100, good, Jacob. And equals what? Good. So, and what would go in for n? 100. Good. Minus 1. So we would say the 100th term of this sequence is 299. Cool. All you literally are doing is plugging in whatever term it is. We plug it in for n to get it out. In this case, 100. We plug 100 in for n to get this out. Okay? Again, this is a infinite sequence. Now, what if I took this and said, find the first 5 terms of this sequence? At that time, we would then be going from an infinite to a finite sequence. Because now I'm saying, find the first how many ever terms? In that situation now, I've moved to more of a finite sequence. Cool? And it's going to have a pattern. You'll see that as we keep going from there. Okay? Questions on this? Pauline?
When it says write the first 5 terms, do you plug in 100?
Great question. Like this right here. If I looked at number 1, where I said, hey, find the first 5 sequence of this number, what we'd be looking for here is attacking this by plugging in 1, 2, 3, 4, and 5 in for n. So in this situation, I would say a sub 1, and we're looking at number 1 here, would be equal to 2 times 1 plus 5, which would be equal to what? 7. Good, Jay. Good. So that'd be the first term of that sequence, right? What would be the second term? 2 times 2 is 4, plus 5 is 9. Good. So we would say that the second term, a sub 2 is how we write it, is equal to 9. Cool? What would be the third term? 11. And you'll see a pattern. What's happening? Adding by 2. Very similar to what you just figured out on the Charlie's Delightful Machine. How you figured out that pattern is very similar to the patterns you'll see here. So 13, and then the fifth term being 15 as well. Okay? So this is, again, a finite sequence because I have a finite number. Okay? But if I said, what about just that formula, a sub n equals 2n plus 5, is that finite or infinite?
Infinite.
It's infinite because I didn't actually tell you find this many terms. Cool? All right? How do y'all feel on that? Pretty simple? So if I took let's say a more complicated one like number 12, right? If I said find the first 5 terms, where would I plug 1 through 5 in for? N, right? Okay? Now again, might be a little more tricky because you actually have to solve it algebraically, but you could still attack it the same way we did up here by, like, let's say on number 12 we'd say, okay, let's find the third term. We do 1 plus negative 1 to the third over 2 times 3. And what's negative 1 to the third? Negative 1, good, Jay. Plus 1 would be 0. So this would be 0 over 6, which is be 0. Good. Yeah, so that would be an answer of 0. So we'd say the third term is 0. Cool? All right? How do y'all feel algebraically? Just plugging in numbers? I told you it's not too bad. Just know the terminology of, we say a sub 3, that means that is the third term of this sequence, whatever sequence we're finding. Okay? All right, to go the next easy thing, this is the last thing before we go into more difficult stuff. Take out your calculator just really quick. I'm going to show you how to do this on your calculator. And the one we're going to do, just so you have a heads up on this, is number 9. Sometimes it becomes a little easier to be able to plug it in your calculator and get it out. So let's do number 9, and let's see if we can check on that. So we're going to go to y equals here. And what you can do on any of these sequences is just plug in for the y1. Plug that equation in of n over n squared plus 1. Cool? So we're literally going to plug in, and except for n, we'll do x. So we'll do, all right, we got x divided by x squared, and then plus 1. Cool? And that's how we would plug in for y1. All right? Just like what you see up here. So again, the one we're doing is number 9. You could do any of these via calculator or algebraically as well. Okay? All right, so far so good? All right, now, just to make sure your calculator's doing the things we want it to, go to second window. All right? Table start, what does that mean?
Where the table starts.
That deserves a ticket. Nicely done. Yeah, it's where the table starts, right? Okay? That is where the table starts. What is the, good question, second window, right next to y equals? What does the triangle table mean?
That's triangle table.
Triangle table.
This right here, so this is where table starts. What does that mean?
Oh, it's to change delta to change.
This is delta, right? Okay? So right here, okay? Delta change, okay? All right? The Illuminati.
What
Alright.
is chalice?
You didn't know that it was the Illuminati, did you? But it does mean table change, okay? Did I just put that on the podcast?
Is the podcast?
Yeah, it is. It is. My apology. My apology. We'll stop there.
The Illuminati.
Make sure that is 1. Okay? Make sure that is 1. All right? All right, so now what we can do now is go to your calculator by going to your table, by going to second graph, and once you plugged in those two numbers, you're going to see that the first, number 1, is the first term, right? And you'll see that it's 0.5, the second term being 0.4, third 0.3, and so on and so forth. You can plug those in and get that out there. Nikki?
What's the second button I was supposed to press?
There's an error there? For this specific one?
I don't know what we're doing.
Do I need to put it in parentheses?
You do that. Yes, that's my fault. I should have said that. Make sure that each of the, if you have a fraction, make sure you put those in parentheses, both top and bottom, because your calculator doesn't recognize that the bottom part is all on the bottom. So that right there is important, right here.
What do you put? I'm confused. Oh,
Okay.
for which?
Go ahead, Kendall. What are you confused with?
Can you like restate?
On y equals, did you plug this in for y equals right here?
That's not
It should be 28 over 19.
Why not?
Did you plug that in?
We put in one off the wrong. We just put in that one and we
Make sure that's got to be in for y equals, and then once you go into the second graph, it'll shoot out that table for you on those terms that you're finding there. Cool. Is anyone having problems on their calculator now? Nikki, are you good now? That shouldn't be undefined now, right?
Yeah.
You're good now? Now, is it possible to have an undefined value sometimes?
No.
Yeah, it is. If you do see error, that just means it's undefined, and you could just put error for that term. You can't have that term, okay? Kendall?
My graph has these dots on it. I know we're not using the graph, but I just don't know what this means.
Remember the dot plot? If you want to take that off, go to second y equals, and just make sure that plot 1, that you take that off there. So you can just press enter, go to off, and that way when you go to graph again, if you wanted to, you won't have that there. Okay. Questions on this? Y'all feel pretty good on doing that on your calculator? Ish?
Wait, okay, so what do
Okay.
we do with these numbers? It just tells you what's
So-
next.
Yeah, great question. So what does this 1 mean?
it's a coordinate.
It is a coordinate, good. In terms of the sequence, right? 1 means that that's my first term.
Oh,
2 means it's the second term. 3, so on and so forth. So instead of plugging 1 through 5 in algebraically, you could do that. This allows me to just say, oh, when I plug 1 in, I'm going to get out 0.5. 0.5 is that first term. When I plug in 2, it's 0.4, 0.3, and then so on and so forth from 1 to 5. Cool? George?
We have to show work still.
You do not. No. You're good. You'll need to know how to do both because like I did earlier, if I said find the 100th term, you'll need to know how to plug 100 in, which seems basic, but is just something that we're going to need to know. And then the second thing, knowing how to plug it in your calculator. This does not need work, though, if you're doing it this way. Cool. Great question. Any questions on this?
I'm so confused.
Okay.
What is that?
This right here?
How would we write that?
Good question. How would we write this? Does anyone know?
We should just like plug it into
correct, if we plugged in 1 through 5 or even all the way to 10, if we plug these numbers in for n, Nikki, then that means that that's what I would get out. So if I plugged 1 in, this is like a sub 1, which means the first term is equal to 0.5 in the sequence that we plugged into y equals. Got me? So if I came over here and plugged into 1, plugged 1 in, I would get out 0.5. Does that make sense? If I plugged in 2, I would get out 0.4. If I plugged in 3, and so on and so forth. Good question. This asks for 5 terms, right? So for the first 5 terms with n being 1, we'll start and we'll plug in and get out 0.5, 0.4, 0.3, 0.23, and 0.19. Those are the 5 terms there. Cool? Pauline, did you have a question?
Yeah, on number, like the second warm-up,
Yes, ma'am.
I plugged that in the calculator and I'm getting all these decimals, but when I did it just like in my head, I got like 12 fifths. So would you want it in decimal form or?
Good question. I would take either or on that. If you, especially that one, would be a longer one, where I wouldn't expect you to probably do that by hand to take all that time up. But knowing how to plug in your calculator like you did, if you just give me the decimal, that's fine. That's perfect. The only exception to that is if I said, what's the 100th term? In that situation, if I just ask for 1, let's get out the fraction form.
How do you plug that in again? Like if you're looking for a specific one.
If I plugged in a specific one, you could just go back and just say, if you went to second window, and let's say I was looking for the 100th term,
You started at 100.
I just start at 100, and then once I go to second graph, then all of a sudden now I've got, okay, at 100, the 100th term is 0.01 in this sequence. Cool? Does that
So-
make sense?
So do you like need to know how to actually do it? Or
By hand is I would say pretty self-explanatory, depending on which one. Like I would put 100 in, divide that by 100 squared plus 1, right? And once I did that, I would get out a decimal or fraction. In that instance, if I said to do it by hand, then you could do it. But if by calculator, you could do it by that way too.
okay.
Does that make sense? Just so you got kind of both with where we're headed. Cool? All right. Are we good so far? We're good? All right. I will tell you right now, the next section, and I'm glad I'm podcasting this because this is something that we're going to come back to. These we've already done. This is just by calculator again. So again, I think we feel pretty good on that. But this section right here, from numbers 39 to 52, is probably, from my experience, one of the harder parts of chapter 8, okay? Now, I will tell you, this is not something that is going to be the extreme part of the test, but it is a small part of it. So understanding like the patterns of what we were talking about at the beginning of today is very important in moving forward, okay? So we're going to start slow, and we'll progress, and then tomorrow we're going to even practice this a little bit more as we continue, okay? All right, so let's take a look at this part. Number 39, all right? I'm going to need some help. See if we can figure this out together, okay? The first term in the sequence is 1, right? The second being 4, 7, 10, and 13. Your job is to create a rule that tells me what the infinite sequence of these numbers are, okay? So the question is what's happening? And Rachel, I saw you. What's happening here? We're adding by 3, right? You'll see that as we go forward, we're adding by 3 for each term, okay? If you see that, here is a strategy that you just kind of know going forward. If I'm adding by 3, we are going to, it seems counterintuitive, but we're going to start by saying 3n, okay? Now, I know what you're thinking, Coach, why wouldn't it be n plus 3? Well, because of the way we do the sequence, if we said just this pattern right here, if I plugged in 1, what would I get out? 3. Plug in 2, I get
6.
plug in 3.
9.
Do you see what's happening? Because we multiply 3 times the number n, whatever n is, we are literally adding by 3 each time, okay? Now question, a sub n equals 3n. Does that produce the numbers that I got up here?
No.
No, it's a little bit off, isn't it? Now it does add by 3 each time, but how far is it off from one number to the next? Like look at the first term. The first term up here was 1.
Oh, so you subtract 1.
Minus 2.
Close, yes.
Subtract 2.
We're going to subtract by 2, okay? Which is good. Because as we go from 3, 6, 9, 12, and so on and so forth, we've got to get back to my original, which was 1, okay? So what I'm going to do is I'm going to take 3n and subtract that by 2. So a sub n equals 3n minus 2, okay? All right? Say that again, I'm sorry.
Why was it the minus 2?
Good question. The 3n came from adding by 3, correct? However, as I look at that pattern, that's a good place to start. But we have to look at our sequence and say, and a lot of times, Mikhail, this is like trial and error. Cool? So the reason why this is tough is because even as the teacher, I've got to try something, and sometimes I might have to tweak it a little bit. So I started at 3n, but I noticed the pattern was 3, 6, 9, 12, so on and so forth. But this pattern is 1, 4, 7, 10, and 13. So it's still adding by 3, so I'm going to keep this, except instead of starting at 3, I need to go back to where? 1, because that's the first term, right?
So basically just figure out like the pattern by like doing like a minus 2.
Correct. And so I'm going to see how can I adjust that 3n to where I adjust it to where I start at 1 and go 4, 7, 10, and 13. Well, I can do that by taking 3n and simply subtracting by 2. And if you want to check, you could check it and say, okay, plug in 1. 3 times 1 is 3, minus 2 is 1, right? Good question. If I plugged 1 in, right, that just means A1 is equal to 1, right? What does A1 mean? A1 just means the fancy term of saying it's the first term in my sequence. And the first term is what? It's 1. If I put like 3 in for n, so I would say a sub 3, which means the third term, right?
Oh, so you don't do anything with that. It's just
Correct. So if I said what's the 100th term, right? You could say a sub 100, meaning the 100th term equals 3 times 100 minus 2. Okay? I know it is a little confusing. This 3,
no, attached to that.
right here, I notice that I'm adding by 3 each time. When I do that, one of the strategies is taking 3 and just saying 3n. Okay? Absolutely. So look at number 40. What's happening on 40? Plus 4. Good. So what's a good way to start this? Equals 4n. Okay? We know that that's a good place to start, but if I plugged 1 in, I get out 4, not 3, right? So subtract 1. Good. So when I do a sub n equals 4n minus 1, this will allow me to have what we call an infinite sequence where I can plug in any number and get out what that term would be at the end there.
Can
Okay?
you do the first one on the homework?
Yeah, what's the first one on the homework?
It's 1/2, negative 1/4,
Yes.
1/8,
Yes,
negative
yes.
1/16.
Okay, let's take a look at this one.
It's 42, 45 up there.
Is it 45 up here? Cool. We'll do that one. That's a good one. So as I look at 45, one thing to note or remember is that if I have a fraction, the easiest way to do this is just to do a rule on the top and a rule on the bottom. Does that make sense? So when I do a sub n, we're going to try this out where if you see a fraction like 45, let's do the rule on top and then the rule on the bottom. Okay? Start with the rule on the bottom and it's much easier. So the bottom is 2, 4, 8, 16. What's happening? Times by 2. Good. So what's going to happen on the bottom rule?
2x.
2x, or we say 2n, right? Okay? And just to check that, I plug 1 in for n and get 2. Plug in 2 and get 4. 3, so we're, hold up. Did we do that right?
Isn't that negative?
Hold up real quick. We messed up on that. It is multiplying by 2, but remember that before, this was adding by 4, right? You remember that?
Yeah.
So it's not 2n, it's 2 to the n power. Does that make sense? So if you see a pattern of multiplying, you're going to use it as an exponent. So 2 to the power of n. Cool? All right, so we're going to try that out. And we look at it and say, okay, if I put 3 in for n, 2 to the third is 8. And we did get out 8 as my third one there. Okay? All right, look at the top. What's happening on the top?
1, negative 1, 1, negative 1.
1, yeah, 1, negative 1, 1, negative 1. Again, these are just doing them. again, it's hard to kind of see it unless we do them. The easiest thing that I would say to approach that with is if I took, what could I do with that to just go back and forth between -1 and 1?
Plus or minus.
Times negative one.
Okay, yes, this is true. And in doing that, if I keep multiplying by -1, when we multiplied, we did a power, right? So what we would say is -1 to the power of n. Okay? Now let's try it. If I plugged 1 in for n, what do I get out? -1. What if I plugged in 2?
Positive 1.
Plug in 3. -1, right? But look over here. It goes from positive to negative, not negative to positive. You see that?
Oh.
So what do I need to do with n?
Subtract one.
Yeah, you could do that. You could subtract 1 or add 1. Either way is fine by me. Cool? So you would put -1 to the power of n plus 1. Here's the kicker. If you are struggling or if you're like, Coach, that's weird, you're not the only one that's ever struggled with it. We're going to look at this more tomorrow. The other stuff should be good. This stuff we'll have to work through a little bit, okay? Say that again. I did, yes,
Look at
ma'am.
whose names are in there.
Thank
We'll podcast again tomorrow. Is that where you were looking?
Wow.
Good, how are your blood annotations?
We're actually fire.
Really?
Yeah.
Good, how are your blood? Good, I want to feel good. How are your blood annotations?
I'm leaving. I've only got to page 124.
Of what you're
That's iconic. That's iconic.